rationalizing the denominator is where we multiply a fractional surd by 1, but really what we're doing is multiplying by whatever our denominator surd is. What that achieves is it gets rid of a surd as our denominator and can often make these a bit easier to work with. So you can see here, the reason that makes sense is the square root of a times the square root of a is just a, so that gets rid of our surd as our denominator. Plus it sounds really cool, rationalizing the denominator. So for our first example, 2 divided by the square root of 3, we multiply by the square root of 3 over the square root of 3. Remember that that is just 1, so multiplying anything by 1 doesn't actually change the value, but it changes the look of the question. So now we have 2 square root 3 over 3, so we don't have a surd as our denominator anymore. For example 2, you don't need to multiply by 3 square root 5, you just need to multiply by square root 5 over square root 5. I've shown a bit of extra working in green there, but you can jump to that final solution if you're confident with multiplying surds. Just a little bit more on the conjugate surd here. So this is when we have 2 terms in our denominator. We basically multiply by the same values, but if it's a negative, we change it to a positive, and if it's a positive, we change it to a negative. So you can see in my little example there, 2 plus 3 root 5 and 2 minus 3 root 5, if we multiply those together, we actually just get the square of our first value minus the square of our second value. So this is difference of perfect squares as well, if you've seen that before. And so 4 minus 45 is negative 41. So let's have a look at our first example. So 1 divided by 3 minus the square root of 6, I multiplied my numerator by 3 plus square root 6, and the denominator as well by 3 plus square root 6. What that does is get rid of our surd as our denominator, as you can see, and I just write it as 3 squared minus the square root of 6 squared. We know that's the case from difference of perfect squares, and that finishes with 3 plus the square root of 6 over negative 27. That can be written in a few different ways. The calculator might display that slightly differently, but yeah, that's the correct answer. So we're going to rationalize these suckers. 2 root 7 over 3 root 5. Again, multiplying our numerator by the square root of 5 and denominator by the square root of 5, and that is going to give us 2 square root 35 over 3 root 5 times root 5 is the same as 3 times the square root of 25, which is the same as 3 times 5, so 15 as our denominator. And I don't believe we can simplify the square root of 35, so that's all good. So that we don't have to write quite as much working, let's do it up here. So that gives us the square root of 15 over 2 square root 9, and that of course is the same as square root 9 is 3, so 6 is our denominator. One more time, multiplying by the square root of 2 over the square root of 2. Just be careful if you have 2 terms as your numerator or denominator, you need to use brackets here. So this is going to give us the square root of 2 plus the square root of 10 all over the square root of 4. You probably could have just gone to the final answer in that form. So this is where we're using the conjugate value, so difference of perfect squares. As you can see, I'm multiplying by the same values as the denominator, but instead of using subtraction, I have used a plus sign. So let's start expanding. So 1 times 3 is 3. 1 times the square root of 2 is the square root of 2. Square root 5 times 3 is 3 root 5. And root 5 times root 2, square root of 10. I don't think there's anything we'll be able to simplify there. So we get 9 minus 2, so 3 plus root 2 plus 3 root 5 plus root 10, all over 9 minus 2, which is simply 7. And that's it, we don't have any like terms, there's nothing else we can do there. So here I'm going to multiply by 8 minus 2 square root 3, 8 minus 2 root 3. We've got brackets everywhere. This could be a bit of a monster, so let's get going. So 1 times 8 is 8. 1 times negative 2 root 3 is negative 2 root 3. Negative root 2 times 8 is negative 8 square root 2. Negative root 2 times negative 2 root 3 is positive 2 square root 6 all over, I'm going to write this out. So 8 squared minus 2 square root 3 squared. Alright, so nothing we can do with our numerators, I don't think. I'm just having a quick look as I go. That's going to give us 64. Now 2 squared is 4, and the square root of 3 squared is 3, so 4 times 3 is of course 12, so now everything stays the same, except for our denominator becoming 64 minus 12, which is 40, no it's not, 52, there you go. Oh, there's a little bit more we can do, hold on. I hope those few milliseconds of waiting weren't too painful. So we can simplify a little further from here. I really should have done this question before I ran the video, but here we go. So I factorized out my common factor of 2 for all of my numerators. So 8, 2, 8, and 2, or negative 2 and negative 8. So factorizing out our common factor of 2 allows me to simplify with my 2 and 52, giving me my final result just here.